The very last phase of the countdown with the launch vehicle enabled, in Russian Kluch na start, meaning key on start. This last phase can be somehow compared with the Ariane 5 synchronized sequence. And then the last preparations of the launch vehicle will be made according to a predefined sequence and leading to a launch at the exact scheduled time, which is 23 hours, 3 minutes and 48 seconds local time tonight.
Some basic facts about Soyuz. 1,780, that's 1780, launches to her credit, going back to Sputnik, you remember. That's a world record. She holds the world's highest demonstrated reliability rate, I should say, close to 99%. The frigate upper stage, the newest part, which was introduced in 2000, has never failed in her roughly 24 flights. 99%, you can't do much better than that.
It's extremely high, and this is due basically because Soyuz is based on a simple design and manufactured with very stringent quality rules, in particular because it's also used to perform manned missions. By the way, Soyuz is today the only launch vehicle that is able to perform manned missions to the International Space Station.
We're going to go to Philippe Roland, you can see him on the left, of Ariane Space, for an explanation of the mission now. We'll be back with more. Don't go away. The second Soyuz launch is quite different from the first. There are 3 times as many satellites, and there are 3 different types. This called for a certain customization of the launcher's upper composite.
It was pretty complicated, integrating 6 satellites under the Soyuz fairing, especially since we were using, for the first time, special structures to encapsulate SSOT, a small Chilean satellite, in the middle of the platform, with 4 other small satellites, ELISA and Pléiades on top. All this on a structure custom built for this launch. The advantage of this Soyuz is that we have frigate, which allows us to fly 6 spacecraft. Pléiades will be separated first, then the 4 ELISA satellites will be ejected sideways to their final orbit. Frigate will be reoriented, then reignited to move to a new position for the SSOT trajectory. We will again reignite this stage 1 hour after liftoff. SSOT will be separated at the right position for the Chilean government.
The launcher's trajectory also varies considerably from the October launch. It's a different mission, which means the ground stations tracking Soyuz are different too.
French Guiana, Bermuda, then continuation of the trajectory over the North Pole, after which he will pass over Jeju in Korea, Lucknow in India, and Perth in Australia.
Nice summary there, good explanation from Philippe Roland. The countdown at this moment proceeding smoothly. All is well here at the space base as we move down to liftoff time in just about 4 minutes. Our cameras are here in Jupiter and on the pad, but the space base, as you know, is a big one, and there are many other people at work at many other places across the CSG, some 1,500 people in all. We're going to take the cameras up there. This is one of those other places. This is the launch operations site where the launch operations manager you saw earlier and his teams. They're much closer to the launch pad than we are. In Jupiter here, we're about 20 kilometers away. They're about 1 kilometer.
Yeah, this is the CDLS, the Launch Control Center for Soyuz, and like on Ariane 5, the team in charge of operating the launch vehicle from this place is composed of 2 major groups. One is in charge of the actual operations and implementation of the various procedures which enable to make the launch vehicle ready for flight. And one is acting as a technical authority in charge of verifying the launch vehicle onboard parameters and addressing any anomaly that may occur during countdown.
Those are the parts that are similar to the Ariane 5 flights, but there's a new bit that's been added for Soyuz, right?
Yes, the peculiarity on Soyuz is that these 2 groups are each divided into 2 subgroups. The first one being dedicated to European systems, led by Jean-Pierre Baillet on the one hand, and by the Ariane program production manager, Denis Schmidt, on the other hand, and the second one dedicated to the Russian systems, led by Dmitry Baranov and by the Soyuz program production manager, Valery Kapitonov.
In the final moments of the final countdown for the second Soyuz flight on French Guiana, you can watch it on the website at arianespace.com. The excitement here has been very high, you can imagine, all week. It's another one of those moments now. All eyes on the computer screens here in Jupiter, all ears at the telephones as we approach liftoff. We should be starting to hear the DDO calling out. There he is, calling out the final operations, and this was one of the umbilicals that were released.
Yeah, we just saw the drop-off of the umbilical connector at 2 minutes and 24 seconds prior to liftoff. So it means that there is no longer umbilical connection with the launch vehicle now, and for customers, this means that there is no longer actual monitoring and control of the satellites. However, for the main payloads, customers may still decide, as did Pléiades, by the way, to use a limited number of last distant connections through the three-stage vehicle, which will remain until liftoff time and also after in case of aborted launch, for instance.
The DDO calling out the electrical umbilicals on the satellites have been released. They drop into a metal basket designed for this purpose of retaining them. I don't know if we saw that or not. But less than 2 minutes to go. Final countdown leads to the simultaneous ignition on the Soyuz of the central core stage and the boosters, followed 20 seconds later by liftoff. Can you please explain for us the ignition sequence? It's different from Ariane's. It'll give people an idea of what to watch for. 20 engines are lit at once.
Yes, the simultaneous ignition of the Soyuz first and second stages means that 20 combustion chambers start to be operated, 4 on each strap-on booster and 4 on the central core. The thrust is built up in 3 steps to enable monitoring of the engine parameters and potentially abort the launch in case an anomaly is detected.
The DDO is going to call out the 1 minute mark.
So these steps are the following. Step 1 is the low thrust level starting at H0 minus 15 seconds. Then at step 2 the thrust is increased a little bit to an intermediate level. This is done at H0 minus 7 seconds. The last checks are performed, and at step 3 we have the full thrust, which is reached at H0 and which enables liftoff.
There goes the gantry. We are ready to go. Watch for that. At minus 3 seconds, the order is given for the third and final phase, full throttle for liftoff. The DDO will call out the final 10 seconds. We'll let you watch and be back once Soyuz has begun her mission.
Début de la séquence d'allumage lanceur. Largage VKM. Allumage lanceur. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Décollage.
Just beautiful. Soyuz lifting off perfectly from French Guiana, beginning her 1781st mission and her second here. Some beautiful shots coming up through the clouds. It's been raining. It's been raining all week, but the skies cleared for liftoff tonight, giving us a fine view of things. DDO says all is well on board. 313 tons at liftoff. That's less than half the mass of the Ariane 5, but remember, Soyuz is complementary, not a competitor to Ariane 5. Lifting 6 satellites tonight, a total payload weighing 2.1 tons. Ariane 5 can lift roughly 4 or 5 times that much, but the boosters are the first stage. That's another difference between Soyuz and Ariane.
Yeah, the strap-on boosters and the central core burn together in this first phase of flight. The 4 strap-on boosters, as you could see, are the 4 tapered cylinders around the central core, each equipped with a RD-1078 engine burning liquid oxygen and kerosene. The thrust is transferred to the rest of the launch vehicle through ball joints, which are located at the top of the cone-shaped part of the boosters, each being attached to the central core by 2 rear struts, which brake at separation once the predefined velocity has been reached.
Tell us something else about the central core. That's also the second stage, right?
Yes, and it uses a slightly different engine, the RD-108A, but it also burns liquid oxygen and kerosene, and it is reinforced on its upper cut at the interface with the strap-on boosters to carry the load supplied by the latter. And the DDO just announced that the boosters were properly separated.
This is what happens up there. I think you saw that on the screen there. 47 meters of altitude, roughly. Can you give us an explanation of the curve on the upper left-hand of the screen?
Yeah, actually the top left is velocity versus distance on ground, and the bottom left provides you with the sight angle, indicating the direction followed by the vehicle in degrees, the altitude in kilometer, and the velocity in kilometers per second.
So our altitude now 77 and climbing our speed to 2 kilometers per second. We're coming up to the next milestone, jettison of the fairing. The fairing consists of 2 half shells, which provide protection for the payloads during liftoff, like Ariane 5. Weighs 1,700 kilos, measures 4 meters by 11. The DDO says everything is fine on board.
Yes, the fairing is the ST large fairing tonight, by opposition to the S small fairing, which used to be the baseline for the first Soyuz frigate flights in Baikonur. It was decided a few years ago to award CSKB Progress with a contract to develop the ST fairing to accommodate larger payloads, and this was made possible by the introduction of the digital control system on the Soyuz vehicle, as the former analog control system was not able to control Soyuz with such large fairing and subsequent increased aerodynamic forces on the upper part.
The fairing built by TSSKB Progress at the Samara Space Center, which also designs and develops the first 3 stages. The satellite's going to 3 different orbits tonight, 3 different altitudes.
We have the announcement
there's the fairing separation. You see how the pyrotechnic cords blowing the fairing away, getting rid of the 1,700 kilos that we don't need anymore. That's the reason why we jettison the fairing now?
The reason is that at this altitude, the air density in the atmosphere is very low, and therefore the aerothermal flux on the launch vehicle is considered low enough to remove the fairing, which was initially used to protect the satellites against heat and against contamination. Of course, as soon as part of the launch vehicle, any part of the launch vehicle becomes useless, it should be jettisoned. And this should be made also knowing that the fall-down areas are such that no property damage, no bodily injury will be caused by the debris on Earth.
You can see the satellites, the top satellite, Pléiades, exposed, and the 4 Hélices underneath. Coming up on the separation of the second and third stage, a particularity of the Soyuz, whereas with Ariane we separate the lower stage before igniting the upper stage, Soyuz does just the opposite. Third stage is ignited 2 seconds before separation of the lower stage, the second stage. The lower part of the third stage, called the skirt, is used to channel the flux of this third stage motor ignition down toward the stage below, where it rebounds, which gives an added thrust, assisting separation. And the third stage skirt is then separated 30 seconds later. We should be hearing confirmation.
Allumage du bloc I.
There we go.
Séparation bloc A, bloc I.
Block E is also another term.
Block E is the third stage, yes.
The third stage. So the third stage has been
Largage de la jupe arrière du bloc I.
ignited, and the second stage has been burned out and separated, occurring right on time. Separation of the skirt 30 seconds later comes at roughly 173 kilometers. About half a minute she climbs 6 kilometers. More of the mission in a minute. Right now, the latest news from Ariane.